Question 12 says, the function f is defined by f of x equals parentheses x plus 3 times parentheses x plus 1. The graph of f in the xy plane is a parabola. Which of the following intervals contains the x coordinate of the vertex of the graph of f? Okay. Very important, we circle the question. If we find the y coordinate, it's all over. Okay, so I'm going to circle the x coordinate of the vertex, okay? And they've only asked us for an interval, so that was pretty nice of them. And they also gave us the equation of the parabola already in factored form. Now, this is super helpful because if we think about the graph of a parabola for a second, right, where f of x is another way of writing y, so we have our y-axis and our x-axis. Well, y equals 0 at the x-axis, okay? And so if I set this equation equal to 0 and I look for my x-intercept, so I have 0 equals x plus 3 times x plus 1, well, I can set these equal to 0 individually. And I get x equals -3 and x equals -1. So right away I have my x-intercepts, which is super useful. Okay, so they happen to be all on the negative side, so I'm just going to adjust my graph for a second. So I have -1, that's going to be one of them, and -2. Now, I don't know the other points on this graph, but I know enough to know that the vertex has to be in between these two. And actually, since parabolas are symmetrical, the vertex has to be exactly between these two. Well, what's halfway between -1 and -3? -2. So I know that the vertex must be here. So the x coordinate has to be -2. So now I just need to look at my answer choices and see which one gives me that range, or sorry, a range that -2 is included in. So -4 to -3, no. -3 to 1, yes. So I found my answer. I could check the other ones. 1 to 3 doesn't have any negatives in it, neither does 3 to 4. So these are out, okay? Now, what I'll say is that it's really important that we found the x coordinate here. If they had asked for the y coordinate, there would be more steps. So just to emphasize that we always want to read the question really closely to make sure that we solve for the correct thing.